Let's read this. We have a nutritionist who works for NASA, and this nutritionist wants to meet certain nutritional requirements and yet keep the weight of the food at a minimum. Okay, so it looks like we're going to minimize some function here. Now, he is considering a combination of two foods, all right? So we're going to have two variables here, which are packed in tubes, all right? So then we're given a bunch of information. Go down to the end and see what we're looking for. How many tubes of each food should be supplied to the astronauts? All right, so we're going to have two types. I'll have an X and a Y, and what do we have? We have a tube of A foods and tubes of B foods. So this is a good place to start. Let's let X equal the number of tubes of food A and Y the number of tubes of food B. And these problems almost always work like this, right? You start off with something up here, then there's a bunch of information, then you go to the bottom or near the bottom, and that's what you're going to be looking for. How many tubes of each food? Well, I got two foods, A and B, and how many tubes of each? So let X be the number of tubes of A, Y be the number of tubes of food B. Now I have two categories here. I've got category A and B. So my categories are going to go across the top, and then I'm going to have some requirements, okay? And then along our rows, we're going to have some characteristics of these foods. So let's go in and read what we have here. Okay, so each food contains what? Protein, carbs, and fat. Okay, I'll fill in the numbers in a minute, but I have three characteristics of each food. What do we have? Protein, carbs, and fat. So down here, I'm going to write we have protein, carbs, and fat. And then there's also the weight of each tube. So I'll put that down. That's another characteristic. But I'm going to separate that off. All right, so let's fill in our numbers here. What do we know about A? All right, so down here, I'm down here in the matrix here. For A, what do you know? Where are we? Okay, each tube of food A contains 4 units of protein, 2 carbs, 2 fat. So 4, 2, and 2. So these numbers are going to be 4, 2, and 2. And for food group B, down here, we've got 3 units of protein, 6 units of carbs, 1 unit of fat. So what do we have? 3, 6, and 1. 3, 6, and 1. Oh, now what are the weights of these? Okay, so go back to A. Oh, A weighs 3 pounds, and B weighs 2 pounds. Those are big tubes, right? So 3 pounds and 2 pounds. Now, what are we going to have for requirements? So what are the requirements? That's going to come down here, right? So down here, we haven't used this yet. The requirement calls for 42 units of protein, 30 units of carbs, and 18 units of fat. Now, I'm going to write those numbers, but I'm going to leave a little space here, and you'll see why. It's going to be, what? Protein is 42, 30 for carbs, and 18 for fat. But we want to meet the requirements. So these don't have to be exactly equals to 42, 30, and 2, and 18. We just have at least that much. Okay, we need at least that much. Now, what I'm trying to do is this. I want to, how many tubes of each should be supplied to the astronauts in order to do what? Keep the weight at a minimum. So what I'm trying to do here is to minimize W. And what is W? Right, so you go down to W here. W is what? 3, now this is X's, right? This is X's. And 2 Y's, right? What is A? A is our X, B is our Y, so we have 3 X's plus 2 Y's. So here, this is going to be, I want to minimize 3X plus 2Y, minimize the weight subject to these constraints. Well, now I've got 3 constraints. I've got 4X plus 3Y is greater than or equal to 42. I've got 2X plus 6Y is greater than or equal to 30. And I've got 2X plus Y is greater than or equal to 18. And of course, X is greater than 0, Y greater than or equal to 0. So this right here, all this, that is the LP. That is the linear program. So when you're asked to write a linear program, you want to write maximize or minimize some function subject to, and then you write the constraints. So to solve this by graphing, I'm going to label these. That'll be equation 1. This will be, well, inequality 2, inequality 3. And I'm going to graph these. So I'm going to get rid of all this business over here. We don't need that right now. So I'll just erase that. Okay, so let's draw kind of long axes here. So let's see, we will have, here's our y-axis, our x-axis, all right, and our origin right here. So let's make tables for each one of these. All right, so for number 1, x and y. So let x equals 0. Now, when x is 0, in number 1, when x is 0, that goes out, you get 3y equals 42. So y is 14, right? 42 divided by 3 is 14. When y is 0, so if you put 0 in for y, you get 42 divided by 4. Then 42 divided by 4 is 10.5. Okay, we're not going to let that fraction bother us. Let's go to number 2. All right, here's our x and y. So in number 2, when x is 0, so when x is 0, put the 0 in here. We get 6y equals 30. So y is equal to 30 divided by 6 is 5. And when y is 0, that goes out and we get 2x is 30, so 15. And then for number 3, we're going to have 3 lines here, x and y. So when x is 0, put that 0 in here. You get y is 18. And when you put the 0 in for y, you get 2x is 18, so divide by 2, x is 9. All right, so let's try to graph these lines. Now, as I look at this, I look at my y values. I just like to do my y values first. It doesn't matter. But the biggest y I see is 18. So I'm going to put that 18 up here at the top. So maybe that's 18. And then what about the 14 and the 5? Well, let's see. Where would, halfway is here, right? Halfway here is 9. Now we got a 14, so maybe 14 is like up here. So let's put the 14 here. This is a problem with this graphing method. It's not real accurate. And then what about the 5? So if this was the 9, the halfway point, 5 would be about halfway there. So maybe the 5 is here. Now what about the x's? The biggest x I see here is 15. So I'm going to put the 15 way out there. And then I've got a 10, 5, and a 9. Oh boy, 10, 5. All right, well that's about a third of the way, right? So if this is 15, right, 5, 10. So what are we going to have? So the 10.5 is maybe here. And then what about the 9? Well, the 9's got to be real close. So let's do our best to graph these. Now what goes where? The 14y goes with a 10.5 x. So that's going to be the 14 and the 10.5. Okay, that's going to be right here. Now the inequality is a greater than this time. So greater than means I'm going to be farther away. So I'm going to go outside that line to the top right. That's going to be farther away from the origin. So I'm going to shade that region. So far we've got all of this out here. Now let's get that second line. So to get that second line, let's see, what happens here? Well, the 5 goes with the 15. So the 5 goes with the 15. So I'll try to draw that line. The 5 and the 15, kind of like right there. And again, because it's a greater than, it's going to be that region away from the origin. All right, so far now we're looking at this region right here for our feasible solutions, all of that. Let's get that third line. Now the 18 goes with the 9, so the 18 goes with the 9. It's going to be here. All right, and then again, 2, because we have a greater than, we're going to shade the outside region of that line, so it's going to be all this. See if I can actually get it. Okay, so what have we got here? We've got this region out here, right? It kind of comes down here, hits here, hits here, hits here, and then it's all this up here. So look at our corner points. We have this is a corner, this is a corner, this is a corner, and this is a corner. Now, we can get these points, right? This point up here at the top, that's just 0, x, and 18 on the y. So that is 0 and 18. Now, I'm just going to come down here. I'll have to get that one and that one, but this one right here I can get. I'm out 15 on the x and 0 on the y. So this one out here is 15 and 0. Now, I need to find the intersection. To get this point here, I need to find the intersection of those lines. But what was this? This line here, that was the 18 and the 9. I should have kept track of these. The 18 and the 9, that was line 3. Okay, so I'm going to write that here. This right here is line 3. What about this line? This connects 14 and 10.5. That's this one. That's line 1. All right, so this one here is line 1. And then what about here? What is that? That's this line here, which is line 1, and this line here, which connects the 5 and the 15, and that is line 2. All right, so this is line 2. Okay, so what I'm going to do is I'm going to, right here, I'm going to solve this system. If I can get it to right, I'm going to solve that system. So I would go to Wolfram Alpha, and I would type in solve. Okay, what have we got? This is the intersection of which lines? 3 and 1, or 1 and 3, right? So I'm going to solve 1 and 3. So 1 and 3, all right, back over here now. Here's 1, here's 3. So let's write them. We're going to have 4x plus 3y equals 42, and 2x plus y equals 18. So in Wolfram Alpha, I would just type that. Now, I did that, and I got this. I got 6 for x, 6 for y. So that point right there is 6, 6. Now, what about this intersection right here? This one right here. What are we intersecting here? Be careful now. You've got to look closely. It's line. Which line is this? Well, I can see it's line 2, and then it's this one here, which is line 1. Okay, so I'm going to use 1 and 2, and I'm going to have Wolfram Alpha. I'm going to type in this. Solve 1 and 2. So 1 is 4x plus 3y equals 42. I've already got that in from the last time I did this. And the last one, which is line 2, which is 2x plus 6y, is line 2, which is, all right, line 2, which is 2x plus 6y equals 30. All right, now when I type that in for Wolfram Alpha, I got this. I got x equals 9, y equals 2. So this point over here is 9 and 2. Let's make a table. Find out which one's the minimum. So here's x, y, and w, right, the weight. So what are we going to have? I'm going to start at the left. So if I start at the left, I'll take this one, this one, this one, and then this one. So if I start at the left up here, I'm at 0 and 18. So I'll put in 0 and 18. This is going to give me, now w is 3 times 0 plus 2 times 18, which is 36. And then let's move down to this point here, 6 and 6. So at 6 and 6, we're going to get, okay, put in 6 and 6. We'll get 3 times 6 plus 2 times 6. So that's 18 and 12. That's 30. Now let's move farther down. Let's move this one. That's 9 and 2. So that's going to be 9 for x, 2 for y. So we'll have 3 times x, but x is 9, plus 2 times y, which is 2. So we're going to end up with, what do we get here? 27 and 4 is 31. And then the very last one down here is x is 15, y is 0. So we'll get 15 and 0. So we'll get 3 times 15 plus 2 times 0. That's 45. Now we're looking for the minimum. There it is, right there. That's the minimum. So So now I'm going to write a conclusion, and I need a little bit of space, so I'm just going to get rid of some of this stuff right here. So what we're asked for here is this, right down here at the bottom here. It says, how many tubes of each food should be supplied to the astronauts? So we need to supply, what's going to give it the minimum? The minimum was going to be 30 pounds when we supply 6 tubes of each. So here's my conclusion. I'm going to say that the weight is minimum, and I'm going to tell you what it is. The weight is minimum. Well, I said I was going to tell you what it is. Let me tell you. The weight is minimum at what? At 30 pounds when, there we go, when we use 6 tubes of food A and 6 tubes of food B.